So today, we're jumping into a fascinating puzzle from the German power grid. You hear about this one state having a massive electricity surplus, but then you also hear whispers about a potential shortage. How can both possibly be true? Well, it turns out it all depends on how you measure it. Let's dive in. All right, check this out. On the surface, the numbers look absolutely incredible. The official data for 2024 says that Schleswig-Holstein, which is a real leader in wind power, produces 227% of the electricity it consumes. That sounds like a home run for renewable energy, doesn't it? A huge surplus. Well, not so fast. Not everyone's buying it. In fact, the source for this explainer is a memo from an engineering professor, Holger Water, and he calls relying on this one single number grossly negligent. Whoa. Okay, so what is really going on behind that impressive figure? Right, so the heart of this whole thing, it really comes down to a basic difference in how we even talk about electricity. You've got the total amount of energy produced over a whole year versus the actual power that's available in any given moment. They are not the same thing. Think of it like this. Energy, the big number measured in terawatt hours, that's like a giant bucket of water you fill up over an entire year. It tells you the total amount you have. But power, measured in kilowatts, that's the flow coming out of the tap right now. And for the power grid to work, the flow in has to perfectly match the flow out every single second. A full bucket is pretty useless if the tap runs dry right when you're thirsty. And the source memo puts it really bluntly. It says that just adding up the total energy for the year is, and I'm quoting here, insufficient for analyzing a dynamic system like the power grid. Why? Because it completely ignores whether the power was made when people needed it or if the grid could even get it to them. And this focus on the wrong metric leads to two really big practical problems. The memo calls it the wrong time, wrong place dilemma. So first, you've got a temporal mismatch. You might get a massive amount of wind power on a super windy night when everyone's asleep and demand is low. Second, there's a regional mismatch. All that wind power is being generated up in the north, but the big factories and cities that really need it are hundreds of miles south. This creates, traffic jams on the grid. To really hammer this point home, the author uses this brilliant analogy. He compares the situation to the infamous butter mountains and milk lakes from old EU farm policies. Remember that? Subsidies led to this massive overproduction that nobody could actually use. It's a perfect image for energy that's being produced, but it's ultimately wasted because it's just too much or too early or way too far away. Okay, so if counting up the total for the year is misleading, what should we be looking at? The memo argues for a much more down-to-earth metric, something it calls guaranteed capacity. Guaranteed capacity is basically the amount of power you can count on a power plant to deliver with a really high degree of certainty, especially when demand is at its peak. It's not about the absolute maximum a plant could produce on a perfect day. It's about what it can be trusted to deliver when the grid is screaming for power. And that is what matters for supply security. Now, this table from the source, it shows the guaranteed capacity credit for different kinds of power plants, all based on real-world data. And as you can see, conventional sources like gas and coal, they have super high ratings, between 85 and 95%. They're very reliable. Now, take a look at the renewables. And when you put that data into a chart, wow, the difference is just staggering. This shows conventional power getting a credit of about 93% guaranteed capacity. Wind power, just 6%. And solar, because, the sun isn't shining during that evening peak demand in the winter, it gets a credit of 0%. Now, this doesn't mean they don't produce a ton of energy. They do. It just means their power isn't guaranteed to be there when it is most critically needed. This huge gap in reliability leads us right to the core argument of the memo, which is this really fascinating, kind of counterintuitive idea, the backup paradox. So here's the bottom line. The problem isn't a shortage of total energy over the year. That 227% number proves that. The real problem is a shortage of reliable, on-demand, instantaneous power that can guarantee the lights stay on during a cold, calm winter evening. And here it is, the punchline of the whole analysis. The memo states, quote, "The backup power plants are needed not instead of wind power, but because of wind power. Since wind and solar come and go, you have to have a completely reliable backup system ready to jump in at a moment's notice, which means you essentially have to build and pay for two parallel power systems." So where do we go from here? Well, the author wraps up by recommending a pretty fundamental shift in how we think about the problem. And it all starts with measuring what actually matters for keeping the grid stable. The recommendations are pretty clear.
First, we need to shift our focus away from these misleading yearly totals and look at real-time power flow. Second, we have to be honest about the low capacity factor of renewables. That's the gap between their potential and their actual output. And finally, grid security, which is based on guaranteed power, has to be the absolute top priority in all our planning.
Ultimately, this whole explainer leaves us with a really important question. It suggests that whether we're talking about energy or the economy or any complex system, the metrics we choose to celebrate are what define the outcomes we get. So if we're measuring success with the wrong ruler, how can we ever hope to build the right future? Thanks for joining us.